Hi there. Today we're going to discuss sequences. Objectives. Today we're going to learn how to describe and extend sequences, and then we're going to write algebraic expressions to represent a sequence of numbers. How to describe a relationship in an arithmetic sequence. Step 1. Find the difference between two consecutive terms. So what you're basically going to do is you're going to subtract any term by its previous term, or the term before it. Then you're going to describe it in words. And then step 3, apply relationship to consider continue pattern if you're asked to do so. So example 1 says, describe the relationship between the terms in the arithmetic sequence 8, 13, 18, 23. Then write the next three terms in the sequence. So the first thing that we're going to do is we're going to have to find out, how did this relationship change? Okay, so we went from 8 to 13 to 18 to 23. Now all we have to do is find the difference between two consecutive terms. So these are two consecutive terms here, 8 and 13, because they come right after each other. So what we're basically going to have to do is we're going to have to subtract the term by its previous term. So we're going to say 13 minus 8. How much did that change? Well, it changed by positive 5. So what we're going to say is you added 5 to 8 to get 13. You're going to do the same thing from 13 to 18. Well, 18 minus 13 is 5, so you added 5 to that. And then from 18 to 23 is the same thing. You added 5 because 23 minus 18 is 5. So now they're going to ask you to describe it in terms. So you're going to say add 5 to the previous term. Okay, and then if we want to continue this pattern, all we have to do is keep extending the pattern. So we're going to say 23 plus 5, and then that equals 28. And then we're going to take 28, we're going to add 5 to that, and that equals 33. And then we're going to add 5 to 33, and that equals 38. So if we're going to continue this pattern, we would say the next three terms are 28, 33, and 30. Okay. Here's another example with whole numbers, and then we're going to move on to rational numbers as well. So we're going to describe the relationship between the terms 7, 11, 15, and 19. So again, we're just going to take our terms 7, 11, 15, and 19, and we're going to describe how did it change. Well, how did we get from 7 to 11? So how we do that is we're going to say 11 minus 7 is plus 4. Okay. 11 plus 15 also, I'm sorry, 15 minus 11 is again 4, and then 19 minus 15 again is 4. So the pattern that we're seeing here is we are saying that we are going to add 4 to the previous term. Oops, spelled that one wrong. Okay, previous term. Okay, so now we're just going to extend. So we're going to start with 19, we're going to add 4. That gives us 23. And then take our 23, add 4 to that, and that gives us 27. And then we're going to take our 27, add 4 to that, and that gives us 31. So our next three terms is going to be 23, 27, and 31. All right. Okay, now we're going to get into rational numbers here. So we're going to describe this pattern right here. So we have 0 0.4, 0 0.6, 0 0.8, and then 1.0. So all we're doing now is subtracting any term minus its previous term. So we're looking at 0 0.6 here. We're going to subtract 0 0.4, and that's positive 0 0.2, which means we added 0 0.2 to that term. Same thing here. We're going to add 0 0.2. Oops, sorry guys. 0 0.2. And then also in the last one, from 0 0.8 to 1.0, you're adding 0 0.2. So if you're describing it in words, you're going to say add 0.2 to the previous term. And then when we're extending it, we're just going to take our 1.0, add 0.2, that's 1.2. 1.2 plus 0.2, that equals 1.4. And then 1.4 plus 0.2, that equals 1.6. So we are going to say that the next terms are 1.2, 1.4, 1.6. What I want you to remember, boys and girls, is that these questions are two parts. They're asking you to describe the relationship and they're asking you to write the next three terms. So you have to remember to answer all parts. All right, here's my last one. This one, we're going to start talking about um, 0.1, 0.5, 0.9, and then 1.3. Again, all we're going to do is subtract the second term from the first one. So 0.5 minus 0.1, that was plus 0.4. Same thing here, 0.9 minus 0.5, that's plus 0.4. And then in the last one, it's also plus 0.4. So our relationship is going to be add 0.4 to the previous term. And then we're going to just continue this pattern. So 1.3 plus 0.4, which is 1.7. Then 1.7 plus 0.4, that equals 2.1. And then 2.1 plus 0.4, that equals 2.5. So the second part to our question is going to be extend the pattern, and this is our extension for the next three parts. Okay, now we're going to talk about how to write algebraic expressions, and this is for geometric sequences. Geometric sequences are different from arithmetic sequences because now instead of adding a number, we're just going to start multiplying. So our step one is to create a table if one's not provided for you. I just find that tables are more helpful to see the pattern that you have here. And then step two, we're going to find the ratio, the change in terms over the change in positions. And then we're going to create the expression kx, where k is the common ratio and x is the term or the position. Okay, so x is going to be the position. All right. So here's example 3. The greeting cards that Meredith makes are sold in boxes at a gift store. The first week the store sold 5 boxes. Each week the store sells 5 more boxes. The pattern continues. What algebraic expressions can be used to find the total number of boxes sold at the end of the 100th week? So here they gave you a table, which is really nice. So in the first week they sold 5, and in the second week they sold 10, and in the third week they sold 15. So we're going to have to find the value of the term, the change in the value of the term, and then the change in the position. So from 5 to 10, it was an increase of 5. 10 to 15, it was an increase of 5. And then the same token in your positions, it's an increase of 1. It's an increase of 1. So if we're going to talk about the change in the term over the change in the position, the terms changed by 5, and then the position changed by 1. So what we're actually multiplying by is by 5. So we're going to multiply the position by 5. So how we do is, next thing we do is we're going to set up the expression kx, meaning we are multiplying the position by 5. So 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. So we are going to say 5 times n. Okay, so now that we have our expression here, now we can substitute whatever we need. So n is the number of weeks, so just 5 times 100, and that equals 500. So At the end of the week, 500 boxes are going to be sold. Okay, so all we did here is we took our table, we found the change in the terms, okay, we found the change in the positions, we found that ratio, which is 5, okay, then we created the expression 5 times the number of weeks, and then all we did was substitute at this point and then solve. Okay, I got one more example for you. So Mehmet started a new exercise routine. The first day he did 2 sit-ups. Okay, so day 1 he did 2 sit-ups. Each day after that he did 2 more sit-ups on that previous day. If he continues this pattern, what algebraic expression can be used to find the total number of sit-ups on the 10th day? Use the expression to find the number. Again, this is a two-part. We need to find the algebraic expression, and then we need to find the 10th day. So on the second day, he did 2 more than that, so he did 4. On the third day, he did 6. And then on the fourth day, he did 8. So the question is, what is this operation here? What did we do? And again, in a geometric sequence, it's multiplying. So we're going to have to find the change in terms, which is here, and then the change in position, which is here. So our terms are actually increasing by 2. So plus 2, and then plus 2. And then our days or our position is actually increasing by 1. Okay, so now we're just going to set up that ratio of the change in terms over the change in position. And when we do that, When we do that, we get 2 over 1, or just 2. So we're basically taking the day and we're multiplying it by 2. So 2 times 2, and then 3 times 2, and then 4 times 2. So that basically means all we have to do is multiply our days times the number 2. So our expression is going to be 2 times the number of days. And I'm using D because it's for days. So now we have to find out how many for the 10th day. So we have 2 times 10, and that equals 20. So altogether, he is going to do 20 sit-ups. Okay, so today we described the relationships and extended terms in an arithmetic sequence. Hope that video was helpful. Thank you. Bye.